Hello guys. So again, same topic, surface area, total surface area, volume of 3D objects, and it is 47th video. So again, it is based on maximum minima, means we will try to maximum volume, minimum surface area. So right now we have a problem. We have a piece of cardboard. It is just like this, and dimension is 24 24. So according to question, we will cut the equal squares from the corners. It is just like this and this. So all the four corners we cut the squares, small squares, and then turning up the sides. So find the that height of the sides for which the volume of the box will be maximum. So when you cut the squares, square means the sides should be equal. So let us consider this is x and x. Again these are x. So the base area will be this. This is the base of the box, right? And these are the sides which we will open up, turn up. So this base will be total is 24, and the when we reduce x on left side and x on right side, so it will be 24 minus 2x. And the same way according to this width, so we will reduce x and x, in total side is 24, so it will be 24 minus 2x. So the base again is the square of side 24 minus 2x and 24 minus 2x, and we turn up this side, these sides of the height x. So the dimensions after removing this of the box, so dimensions after removing the squares from the corners, then length will be 24 minus 2x, width will be 24 minus 2x, and the height will be x. So the volume of box will be L into B into H, that is 24 minus 2x, 24 minus 2x, and x. So you can say it will be V equals to 24 minus 2x whole square into x. And our task is to maximize the volume. So we will use second derivative test on this volume function. Now volume function V is 24 minus 2x whole square into x. So on applying second derivative test, the first derivative of volume with respect to x will be, we will use the product formula. So the differentiation of the first part, that is twice 24 minus 2x into minus 2 and x as it is, plus 24 minus 2x whole square as it is, and the differentiation of x is 1. So on taking 24 minus 2x as a common factor, we get minus 4x plus 24 minus 2x. So we get 24 minus 2x and 24 minus 6x. So it is your first derivative. Now we go for second derivative, that is d2v over dx square. So again we use product formula. We will differentiate first part, we get minus 2 and 24 minus 6x as it is, plus we get minus 6. So it is minus 48 plus 12x minus 144 plus 12x. So you get overall it is minus 192 plus 24x. This is second derivative. So right now we will obtain the value of x for maximum volume. So first derivative will be 0. So dv over dx, that is 24 minus 2x and 24 minus 6x equals to 0. So now we get x is 12. By this factor x is 4. So this can't be possible because we cut the squares of x and x. So if it is 12 and this is 12, so 24 is the only side, so nothing will be remaining, so no base area, so it can't be selected. So answer is this. So right now we have d2v over dx square is 1 minus 192 and so d2v over dx square is negative. It shows the volume of box shows maxima. So x is the height of the box. So this was the our question, the height of the box. So height of box, it means 4 centimeter. So this is your answer. So right now the question of maxima minima for 3D object is cylinder. So right now we have a cylinder of maximum volume. So the volume is maximum, and this is your proving condition, and this is inscribed in a sphere of radius r. So radius is given, it is your GC, and intermediate condition is height of cylinder is 2r root 3. So we want to collect this value as a intermediate condition. So let us consider a cylinder is inscribed in a sphere of radius r. So AC is diameter of the sphere, and it makes an angle theta with AB. So angle CAB is theta. So in triangle ABC, the cos theta is base over hypotenuse. So it is AB over AC, and AB is the diameter of this cylinder, and AC is diameter of sphere 2r. Means AB equals to 2r cos theta, and this equals to 2r. So the radius of cylinder is r cos theta. And what about the height? So we want BC. So in triangle ABC, if we take sine theta, so sine theta is perpendicular BC and hypotenuse is AC. So BC over 2r. So BC equals to 2r sine theta, and BC is height of cylinder. So right now we have these two parameters by which we can collect the volume. So right now we have radius of cylinder is as r cos theta, and height of cylinder is 2r sine theta. So the volume of cylinder V equals to pi r square h. So we put the values of these in this expression. This is pi r cos theta square and 2r sine theta. So V equals to pi r cube cos square theta sine theta. This is the volume expression for the cylinder, and we have to show it is maximum. So for proving this volume is maximum, we will use second derivative test. So according to this, first we collect dv over d theta, first derivative. So pi r cube as constant is common, and the product rule on cos square theta sine theta. So we get 2 cos theta into minus sine theta into sine theta plus cos square theta into cos theta. So pi r cube, and we will take cos theta as common. So it is minus 2 sine square theta plus cos square theta. So we have these two factors, dv over d theta. Now next step, we put it as 0. So dv over d theta means pi r cube cos theta and cos square theta minus 2 sine square theta equals to 0. So the values, cos theta equals to 0, so theta is pi by 2, which is not accepted, otherwise cylinder will not be formed. And second one is cos square theta minus 2 sine square theta equals to 0. So it comes here, and sine square theta over cos square theta is 1 by 2. So tan square theta, so we get tan theta equals to 1 over root 2. Now we have V is pi r square h. On putting values, we get V is pi r cube cos square theta sin theta, and dV over d theta is pi r cube cos theta into cos square theta minus 2 sin square theta, and we, on solving this equal to 0, we get tan theta equals to 1 over root 2. On further differentiation, we will obtain second derivative, that will be pi r cube minus sin theta cos square theta minus 2 sin square theta plus cos theta into 2 cos theta into minus sin theta minus 2 sin theta into cos theta. So pi r cube, and there is minus sin theta cos square theta minus 2 sin square theta cos theta, and this is minus 2 sin theta cos theta, and this is again minus 2 sin theta cos theta. So it is pi r cube, we get minus as common, so it is sin theta and cos square theta minus 2 sin square theta plus cos theta into 4 sin theta cos theta. So minus pi r cube, it is sin theta cos square theta minus 2 sin cube theta and plus 4 cos cube theta into sin theta. So on putting the value this, so according to this we have tan theta, that is perpendicular over base. So perpendicular is 1 and base is root 2, so it will be root 3. So according to this, sin theta is 1 over root 3 and cos theta is root 2 by root 3. So on putting these values in this expression, minus pi r cube, we will place sin theta is 1 over root 3 and cos square theta will be 2 by 3 minus twice of sin cube theta, that is 1 over 3 root 3 plus 4 cos cube theta is 2 root 2 over 3 root 3 and sin theta is 1 over root 3. So according to this, these will be cancelled out and we get 8 root 2 over 9 and pi r cube. So on multiplying this we get negative. So d2v over d theta square is negative. That shows volume of cylinder in a sphere of radius r is maximum. And one more thing, we want to show that the height of cylinder is 2r over root 3. So height of cylinder small h, or you can say bc, equals to 2r sine theta. So it is 2r and sine theta is 1 over root 3. So we get 2r over root 3 as the height of cylinder. Hence proved.